So we're studying about polar coordinates in this section. Sometimes the real life problem, we can somehow model it and give it some equations in math to describe some things happen in real life. We want to solve them, but somehow in Cartesian coordinate, it becomes very hard. So Newton defined a new system, polar coordinates, where the two variables are now the r, the distance from the origin to the point, and the angle theta. For example, we normally deal with the OX or Y coordinate system like this one. For example, OX or Y, right? And a position here, any point P here, we project to the OX axis and we project to the OY axis. It is a Cartesian coordinate. But in the polar coordinate, we pick the x-axis will be the same as in the Cartesian. And another one is the angle. For example, any point P here, the r is the distance from this origin to that point, and the theta angle. We define that the positive angle is going counterclockwise. This is the positive direction. And 0 is right here. And the negative direction will go in the clockwise direction. Okay. Now, for example, in polar coordinate, let us do some example. First, look at the example here. The point, let us do together here. Okay. One more thing. Sometimes, we use negative. The distance is not negative, right? But convention here, if a point in polar coordinate, for example, represented by r and theta in this point here, and we define that the negative r will be the point which is symmetry about the origin here. For example, negative r theta will be, we find the r theta first, and the negative r theta will be the point which is symmetry about the origin here, which is this point, right? Then this point here, the coordinate of that will be negative r theta, or it is the same as r, and what is the angle from here to here? Yes, right. So one point here is represented by two coordinates, right? I mean, two different numbers here, right? It is not unique. A point in Cartesian coordinate, it is unique, but in this coordinate, it's special. Okay, now let us play with some specific example here. Okay, take a draft of paper and draw it yourself. Try. Let us do it together first. The question A, and then B, C, and D. You try to do it yourself, and we'll correct it. For example, here is the x coordinate, right? And let us call that here is 1, this is 2, right? And so r is 1, and the angle theta will be 5 pi over 4. Here, if we go from here to this, it will be, what is it? What is the angle? If we go from here to here, pi over 2, right? And 5, if we continue, then the angle right here will be so 3 pi over 2, 3 pi over 4, right? So on and so forth. And 5 pi over 4 will be this guy, right? The big angle right here. Okay. So then the radius of that is 1. It means that the distance from that point to the origin will be 1. And let us count. Okay, for unit, it would be somehow here, right? Okay, this point here. And let us draw this line. And we know we call this is R, right? And remember, in this case, R is equal to 1. Okay. So now pick, yes.
Where do you start, like, measuring from?
Yes.
Do you start from
Very good question. We will always start here. The angle of theta is equal to 0 on this line. Angle of theta is here. Yeah. And it is measured in radians. Okay. Very good question. Thank you. So is it clear for the first example here? Very good. Now, let us do the question B and try to do it yourself first. Okay? We will correct it together so that you will memorize it better. Alex. Sorry. Very good, but do not use your phone while in class. Okay, now let us try the question B here. So the coordinate is right here. Suppose, imagine this is x coordinate. Okay, let us pick the unit. 2 is right here. 1 is right here. So for so any point which has the radius 2 will be on this circle, right? Oh, I mean, it should be here for unit. Will be on this circle. Imagine there's a circle here, right? And the angle is 3 pi. It means that we start from here, 0 on the OX axis. We go up to this point, the positive direction. This is 1 pi. And 2 pi will be here, right? And 3 pi will be right here. And the point here will be the point 2 and 3 pi. Okay? So you can imagine that the angle will go from here to pi and go one more. Okay? The distance from that point to the origin is 2. Okay? How about the point in the question C, 2 and negative 2 pi over 3? Okay, 2 pi over 3. So remember, in order to find the correct point on the coordinate, it is a trick. Pi over 3 pi over 3 here, right? 1, 2 square root of 3. What is cosine of pi over 3? Yes, 1/2. This is the special triangle, right? It means that in a cosine axis, if we pick the unit of this, here 1, it means that cosine of 1/2, imagine it should be somewhere here. It cut the coordinate. Okay, I don't know. I think it's better to imagine it here. Suppose this is 1 pi over 3, right? Then the negative, it means that we go into the negative direction. To go from here is 0. This is 1 pi over 3, right? The whole thing here is 1 pi, and this is negative 1 pi over 3. Therefore, 2 pi over 3 will be up to this one, right? And it is going in the opposite negative direction, negative 2 pi over 3. So, and the distance here will be two, right? Okay, this is the point 2, negative 2 pi over 3. Okay. Is that okay? Okay, cool. Then, similarly, here, the R is 3, is a negative 3. It is a negative number. Theta is 3 pi over 4. Do the similar things. But in this situation, we do it this way. The angle 3 pi over 4 will be like this. Okay? 3 pi over 4. But the R, the radius is negative 3. Suppose you have this line would be extended like this guy. Here, we will find the angle first. And suppose the point P here is 3 pi over 4, right? In order to find the negative, the angle, the point with the negative radius, we find the point with the positive radius first, which is 3 pi over 4. Then the point which is symmetric to that point with respect to the origin is the point we are looking for, this guy. Okay? That's it. Just a new concept. Is it clear how to determine a point in the polar coordinate? Very good. And somehow we see that it is not unique. For example, the point here at r theta, right? Theta is a given angle. Then we go one more round, right? We walk to add 2 pi to this angle, which is r theta plus 2 pi. It will finish one circle and it go back to exactly this point. So this point will be represented by an angle and 2n pi, where n is an integer, right? We can go in the positive direction or the negative direction, okay? It is not unique. And in order to find the relation between Cartesian coordinate and polar coordinate, it is given by this. If the position pxy is in Cartesian coordinate, in polar coordinate it is r theta, and the relation between x, y, and r and theta here will be given by this guy. Right? It's clear that cosine angle, cosine theta here is x over r, right? And sine will be y over r. Okay, provided that this angle is right angle. Very good. Therefore, from that we have the relation that okay, x is r cosine, y is r sine. Okay, this is just an illustration. And in general, we have this relation between the polar coordinate and Cartesian coordinate. X squared plus y squared is equal to r squared, and the tangent theta here will be y over x. We have this relation because you can take a look at this equation here, right? We take this equation, divided both sides, right? Sine theta divided by cosine theta will be y over r divided by x over r. Therefore, we have this relation. Okay. So now let us do the example here. Convert the point 2 pi over 3 from polar coordinate to Cartesian coordinate. Now take a piece of paper, or if you don't have, you can come here on the table and take one. Do it yourself using these relations. Okay, do you find it? Matthew, what is R in this case? Mia? Trinity?
Would it be 2?
Yes. In the polar coordinate, this is R, right? Therefore, R is 2. And what is theta?
pi/3.
Yes. Okay. So the relation is this. X is R cosine theta, right? Y is R sine theta. We're given R and we're given theta, right? Therefore, what is X? Yeah, what is it? R is 2 and cosine of pi over 3. So what is cosine of pi over 3? Yes, which means 2 times 1/2. And it is? Yes. And y? Yes. Therefore, it is square root of 3, right? Very good. Thank you, Mia and Trinity. So we found x and y in polar coordinate, in a Cartesian coordinate, right? It's easy. Very good. Now the next example, represent the point with Cartesian coordinate negative in terms of polar coordinate. Okay, this is interesting. So now from Cartesian to polar. So in Cartesian coordinate, it means that x will be 1 and y is negative 1, right? So we can draw it if you want. It is this point, right? Okay. Therefore, what is r in polar coordinate? Then r will be square root of 1 square plus negative 1 square, right? Which is?
Square root of 2.
Yes, perfect. So r is square root of 2. And what is tan theta? Yes, negative 1 over 1, which is negative 1, right? Remember the unit circle. This is cosine axis. And the tan axis is this line, right? So the negative is when y is equal to x. So when tan theta is equal to -1, therefore theta would be,
Negative pi over 4.
yes.
Although I know it's always going to be negative variable.
It should be, if we go in the negative direction, it would be -1 over negative pi over 4, right? Or it could also be, what is it here? First, 3 pi over 4 first, right? Or the second will be 3 pi over 4. If we go one more half of round here, it will be 7 pi over 4, right? So there are many angle theta could represent it, yes.
One negative 5 and 4 and 7 5 depending on what direction.
Yeah, it indicates the direction. Negative pi over 4, it means that we go into negative direction, where positive direction will go this way. Okay? So it means that we could write it in polar coordinate as square root of 2, and theta will be negative pi over 4. This is a solution, right? Or square root of 2 and, but be careful, 7 pi over 4, right? Sorry? Look at this.
It's the same color for 1, -1, 1, 4.
We may, yeah, it's very important to know which quadrant it is, right? So here, tangent theta will be y over x, which is a, okay, how to explain it?
The strategic coordinate they give us is 1, -1, which is quadrant 4.
Yeah.
The polar coordinate will also be.
So remember, this point is in the quadrant 4. So it means that in polar coordinate, it should also be in the quadrant 4. Okay? But the point here with theta is 3 pi over 4, it is in the quadrant 2. Right?
So you're going to put negative square root of 2, 3, 5, 4.
Yes. If you put negative square root of 2 and here 3 pi over 4, this is correct. So these are all the possibilities. Okay. Are we good? So it's very important which quadrant it is. Okay. Oh, this takes longer than we expected, right? Okay, and now let us move on to another concept, polar curves. So functions in coordinates, we know we study a lot in part 1. So we can do this way. For example, we pick some values. Okay. In Cartesian coordinate, y is equal to fx. Given a value of x, we can compute the value of y, right? And then plot that point into the 2D graph. The same thing would be applied to polar coordinate. If we write r as a function of theta, then the curves will be the curves f theta of this function, or in general, we can write it as capital F of r and theta is equal to 0, it will consider all the points and yeah, here. For example, the curve is represented by the polar equation r is equal to 2 should be this red line here, right? This point, for example, here, this point is, what is the coordinate of this guy? The distance from this point to the origin is 2, right? Therefore, the r will be 2, and what is the coordinate of theta at this point? 0. Very good. It's satisfying this equation, right? X is equal, r is equal to 2. How about this point here, where theta is equal to pi over 2? Right? It is also the point satisfying this equation, r is equal to 2. The collection of these points give us a circle, right? Okay. Similarly, if r is equal to 4, it will be this blue circle here. Okay. The next example, sketch the curve r is equal to 1 plus sine theta. It's interesting. R is equal to 1 plus sine theta. Okay. So if we do the similar things, okay? If we pick a value of theta, we find an R, right? Let us write. So if theta is 0, pi over 4, and then let's just pick 4 points. Pi over 2, pi, 3 pi over 2, 2 pi. What is the corresponding values of R here? Yes. And 2, right? And at pi, 1, 0, very good. And at 2 pi, sine of 0 is 0, right? If we go over 2 pi, it will be repeated because it's periodic, right? And in Cartesian coordinate, okay? Look at this. This is the sine function, right? If we plot r and theta here in Cartesian coordinate, so let us zoom it in here. This is the sine function. It is shifted up 1 unit. This is how this function is represented in the Cartesian coordinate. At 0, it is 1, right? Imagine in Cartesian, the x coordinate is the angle theta. This is r. Okay. At pi theta is equal to pi over 2, it goes rise up to this point, 2, right? At pi, it decreases to this point, and 3 pi over 2, it would be this point, and this point. This is in Cartesian. However, if we plot these pairs, so the pairs here will be the points. The points here will be 1, 0, right? This is 2 pi over 2. This is 1 pi. This is 0. 3 pi over 2. And here is 1, 2 pi, right? Let us plot it in polar coordinate. In polar coordinate, here, the origin O, 1, R is 1. I think it's less confused if I draw it this way. In polar coordinate, the point 1, 0, it means that the distance from the origin to that point will be 1, and the angle theta in this case is 0. This is the point, right? In polar. At 2 pi over 2, it means that if the angle is pi over 2, it will be this point here, right? The distance from that to the origin would be 2. So this guy is 2 pi over 2, right? How about the point 1 pi? Yes, on the left, it would be right here. The angle theta here is pi, right? And it would be this point, 1 pi, okay? And at 3 pi over 2, 3 pi over 2, oh, yeah, 3 pi over 2, which mean here, and it go back, R will be 0, it is this origin, right? And at 2 pi, it go back to this point, right? So if we pick for more values here of theta, we will have, this is how it changed from 0 to pi over 2. And the whole plot of that will be like this, okay? This is the sketch of this function in polar coordinate system. At 0, it will be at this point, right? Here is pi over 2, it goes this way, right? And at pi, it will be right here. 3 pi over 2, it goes to this point. And from 3 pi over 2 to 2 pi, it will be from here to here, right? It's a little tricky in this. Is it clear how to plot a curves in polar coordinate? Say it again, please.
So whenever it goes from 1 pi and it goes to 0, 3 pi, we just throw it over.
You mean these values? We, in polar coordinate? Because here the sine function, it is periodic. And the period is depending on the sine function, right? It is periodic from 0 to 2 pi. That is why we pick these values from 0 to 2 pi. And from, for example, if from 2 pi to 4 pi, this value will be repeated, right? It is periodic. So it is enough to pick these special values from 0 to 2 pi. And here, for example, because we don't pick too many points, but if you pick 4 more points at pi over 4, you can see that at pi over 4, it will be this point, right? The angle theta is here, and the distance you have to compute it to see the distance from this point to the origin here, but it's satisfying the equation. Yeah. So it depends on the problems. So we can pick from which intervals that is the most convenient for you. You can definitely pick from 2 pi to 4 pi. It doesn't matter, or from negative 2 pi to 0. But the thought would be the same, right? Alok?
So when we're graphing these, do you want us to graph it like the, I guess, little arching right there, or like the sine function?
So yeah, so here is sketching this in the polar coordinate. You're supposed to sketch it this way. Okay. Here is just a comparison, and see here, it is expressed in Cartesian coordinate. It means that we pick the angle theta. Let theta is now theta and r is represented this way, right? Because imagine the same ways in Cartesian coordinate, but instead of x, we have theta here, this, and y we replace by r. That is why it has this shape. Yes.
But you want us to use the other graph?
Yeah, if in the test, I'll indicate which one you wanna. But here in this example, just a comparison between the two ways of expressing this. Okay. And very important properties here is the symmetry properties. So if we know the symmetry properties, then we can graph it faster. Okay. For example, in polar coordinate, if theta and negative theta give us the same result, then it is symmetric about the polar axis. This is the polar axis, right? Here. For example, here, this point, theta, r theta. And this point is r negative theta. The angle is theta negative theta, but the distance, they are the same. So we call it symmetric about the polar coordinate, right? Symmetric this way. For example, the fastest example is this function. R is equal to cosine theta, right? Because the cosine function is an even function, right? Cosine theta is equal to cosine of negative theta. So if you try at home, or you can play with 1 plus cosine, you see that this will be symmetric about the polar coordinate. The similar things, if the equation is unchanged, if we replace r by negative r, then it is symmetric about the pole. It means here. Okay, the pole is at the origin. If the equation is unchanged, when theta is replaced by pi minus theta, it is symmetric about the pi angle theta is equal to pi over 2. And tomorrow we will continue with some other concepts. I'll see you tomorrow.